welcome back to this course. In this video, I would be teaching you about logical and bitwise operations. So you might remember that in the first video, I taught you about AND, OR, and XOR boolean logic. So that is exactly what we would be doing, but we would also be doing some things extra than that. So let's first learn about logical operators. In an if statement, if we want to add on two conditions, then we can use AND or OR operator. So let's say there is a variable a which is equal to 12, and we have a condition which says if a is greater than 12, do something. But we also want to make sure that a is I'll just change that. A is greater than 6, and we want to make sure that it is also less than 20. So the way we can do that is we can tack on another condition by saying and a is less than 20, print a. Okay, print a. So it gives me 12. The reason this error was there because after the colon, I had forgot to put an indentation in the shell. So it gives me 12 because these conditions are met. Now let's say you want to print when either of these conditions are true. Not both, but even one of them. So there you use the OR operator. Or then print a. So we get 12 again. We have another logical operator which is the NOT operator. So it basically just reverses the whole output. So not true is false and not false is true. So basically if I add not here, then a would not get printed. If not or not, then it won't get printed. Print it won't get printed, as you can see here. Bitwise operators, as the name suggests, deal with binary data. But since we haven't been dealing with binary data, they seem intimidating at first, but don't be afraid of them. They are very, very easy. The first one that we have is complement, and it is written as the tilde operator. So what it does is that it gives the binary complement of the number which it is added to. So now let's learn the next thing, that is AND. So in binary we have AND. So if I say 3 and 7, it gives me 3. Now let me do something like 23 and 12, it gives me 4. Now you might be wondering how it exactly happens. So we do remember that 23 was written as 1 0 1 1 1. Let's see what is the binary of 12. So 12 is written as 1 1 0 0. So 1 1 0 0, and then we can just add the zeros here. Oops. So you remember the boolean logic, I assume. So 1 and 0 is 0, 1 and 0 is 0, 1 and 1 is 1, 1 and 0 is 0, 1 and 0 is 0, 0, 0, 0, so they'll all be zeros. So the binary number that we get in output from their AND operation is 0 1 0 0. I'm writing it in nibble form. So here, let's just evaluate it. 2 raised to the power 0, nothing. At 2 raised to the power 1, nothing. At 2 raised to the power 2, we have 1. So this would get us 4. So this is why it returns 4. So now that we're done with AND, let's do OR. So 12 OR is written with a pipe like this, or 12 or 23, and it gives us 31. So let's evaluate that now. I'll do it with blue. So 0 or 1, 1, 0 or 1, 1, 1 or 1 is obviously 1, 1 or 1, 1, 0 or 1, 1, and we have 3 zeros here, so that would give us nothing. So at 2 raised to the power we have 1, so 2 raised to the power 0 would be added. 2 raised to the power 1 we have 1, so 2, 1 would also be added. 2 raised to the power 2 we have 2 here, so 3 and 4. 2 raised to the power 3 and 2 raised to the power 4. So this becomes 1 plus 2 plus 4 plus 8 plus 16. So 3, 7, and we have 15 plus 16, 31. And that is exactly what our output is. Now let's move on to XOR. Now XOR is done with the cap operator. So XOR 12 XOR 23, and it gives us 27. Now let's evaluate why that happens. Let me just get rid of this, and we can focus solely on this part. So 0 or 1 is 1, 0, 1, 1, 1 or 1, 0, 1 or 0, 1, 0, 1, 1. So at 2 raised to the power 0 we have 1. So 2 raised to the power 2 we have 1. 2 raised to the power 2 we have 0. 2 raised to the power 3 we have 1. 2 raised to the power 4 we have 1. So all of this would get added. 11 and 11 plus 16, 27. So here we get our answer for 27. Now we have two more bitwise operations that you should know, and that is left shift and right shift. So let's get back to this here. So let's take 12 for example. 12 has 1, 1, 0, 0, and each number also has decimal numbers behind it, obviously, like this. So 12 is 12.0 basically. So what we can do is we can shift these numbers here, or we can shift this there. So that is how it works. So in left shift, we're basically shifting those numbers towards here, towards the left side, and we'll just shift them here. So 12, and then left shift is written as 2 less than signs, 2. So we'll just shift 2 of these numbers this way. So this gives us 48. And similarly, we can shift 2 of these numbers that way. That would give us 3. So 12 moved here by 2 places is 3. So that becomes 11, and this is 1 plus 2 raised to the power 1, so 2, and that gives us 3. That is how I did that. Okay, so that was it about logical and bitwise operators. Thank you so much for watching, and goodbye.